Please subscribe and you can download this code from description below. Title: Why is if not someobj better than if someobj equals none in Python? Introduction. In Python, there are multiple ways to check if a variable or object is considered empty or none. One common approach is to use conditional statements, such as if not someobj and if someobj equals none. In this tutorial, we will explore why the former is generally preferred over the latter and provide code examples to illustrate the differences. Understanding the Pythonic way. Python encourages writing clean, readable, and idiomatic code. When it comes to checking for the absence of a value or an empty object, using if not someobj is considered more Pythonic because it follows the principle of truthiness and falsiness in Python. If not someobj, the Pythonic approach. The expression if not someobj checks for the truthiness of someobj. In Python, many values evaluate to false in a boolean context, such as empty lists, empty strings, and the special value none. Therefore, using if not someobj is a concise way to check if someobj is not empty or is not none. Example. Benefits of if not someobj. A. Conciseness. The if not someobj approach is more concise and easier to read. B. Handles multiple falsy values. It works for various falsy values, not just none. C. Avoids redundancy. It avoids redundant comparisons, making the code more efficient. When to use if someobj equals none. While if not someobj is generally preferred, there may be cases where explicitly checking for none is necessary. For example, when distinguishing between none and other falsy values like an empty string or zero. Example. Conclusion. In Python, if not someobj is the preferred way to check if a variable or object is empty or none because it aligns with Python's philosophy of writing clean and idiomatic code. It is concise, handles multiple falsy values, and avoids unnecessary redundancy in your code. However, there are situations where explicitly checking for none may be necessary to distinguish between different types of empty values. It's essential to choose the appropriate approach based on the specific requirements of your code. Title: Building Python C extension modules for Windows. Introduction. Python is known for its extensibility, allowing you to write C extension modules that can be imported and used like regular Python modules. In this tutorial, we will explore the process of building Python C extension modules on a Windows platform using Visual Studio. We'll walk through the necessary steps and provide a code example to demonstrate the process. Prerequisites. Steps to build a Python C extension module on Windows. Write your C extension code. Create a C source file, example my_module.c, containing your C extension code. Ensure that it includes the necessary Python header files and functions. Here's a simple example. Set up the build environment. Open Visual Studio and create a new C++ project. Choose the DLL project type, and configure the project settings to use the appropriate Python interpreter. Build the C extension module. Build the project using Visual Studio. This will generate a DLL file, example my_module.dll, in the project's build directory. Test the extension module. Create a Python script to test your C extension module. Run the Python script, and it should import your extension module and execute the hello function, displaying hello world. Distribute the extension module. If you want to distribute your extension module, you should package it along with the DLL and any other necessary files. You can use tools like setup tools to create Python wheels or installers for distribution. Conclusion. Building Python C extension modules on Windows involves writing C code, configuring Visual Studio, and linking against the Python library. Once the module is built, it can be imported and used like any other Python module. This allows you to leverage the performance benefits of C/C++ code while seamlessly integrating it into your Python projects. ChatGPT.